These are notes from Elham's Math 60 for Thursday, April the 23rd, section 9.3, page 784. We are all graphing on this section the graphs of exponential functions. An exponential function looks like a constant base raised to an exponent, and the exponent has the variable. So for instance, 6 to the x, 1/5 to the x, 3 to the x minus 1, negative 3 to the x, and so on. The key idea is that the exponent is the variable, has x in it. So these are called exponential functions, and we're going to be graphing these. Right? Now I've separated the notes for each problem with the graph because I just wanted to show you a table for each and what the graph looks like. So here's number 20. The assignment was all graphs 19 to 34, so I did some of the evens for you. F of x equals 6 to the x. You might recall when it says f of x or g of x or whatever, it's the same thing as y. So I made a little table of x and y that goes from -2 to 2. Now, -2 to 2, it's nothing special about that except they're easy numbers, and it gives you enough points to see what the graph is. So that's usually good enough. All right, so I plug in from -2 to 2 and see what the y value is. So if I plug in 0, you might recall that anything raised to the 0 power is 1. So 6 to the 0 is 1, 1/5 to the 0 is 1, and so on. You plug in 1, 6 to the 1 is 6. Plug in 2, 6 squared is 36. And now for the negative exponents, and by the way, you may notice I did this in class quite often. Sometimes it's easier to plug in 0 and 1 and 2 and then go back and do the negatives once you kind of figure out what's going on. Plug in -1. 6 to the -1, you might recall, means 1 over 6 to the first power, or 1/6. And then if I plug in -2, I have 6 to the -2. That means 1 over 6 squared, which is 1 over 36. Okay, so I plot these points. 0, 1 is like here. By the way, you notice my scale, I didn't leave any space for negative y's because none of these y values came out to be negative. So I just went from -2 to 2. Notice I didn't count 1, 2, 3, 4, 5 up to 36. That's just going to take too long. So it looks like in this case I counted by 5s. You can always change the scale. So I went 5, 10, 15, 20, 25, 30, 35, up to 36. So 0, 1 is down here. 1, 6 is a little bit higher than 5. 2, 36 is way up here. These numbers, 1/6 and 1 over 36, are practically 0. So I graphed them really, really close to the x-axis. So the graph looks something like that. Here's 24. F of x equals 1/5 to the x again, but then you can say it's y. All right, and again, I'll start with the zeros and positive. 1/5 to the 0. We know anything to the 0 is 1. Plug in 1. 1/5 to the 1 is just 1/5. Plug in 2. 1/5 squared is 1/5 times 1/5. That's 1 over 25. Now for the negatives, 1/5 to the -1, you might recall that means take the reciprocal of the base, you flip it as 5 over 1, but 5 over 1 is just 5, raised to the positive 1, so that's going to be equal to 5. Likewise, if you plug in -2, 1/5 to the -2 means flip the fraction, you get 5 over 1, raised to the second power, and that's 25. All right, so here's the graph. Once again, I have no negative y, so I don't devote any space to it. I went from -2 to 2 for the x direction. For y, I got to go up to 25. Again, you nor I feel like going 1, 2, 3, 4, 5, 6, 7, so I count it by 5s. Again, 5, 10, 15, 20, 25. Okay, so -2, 25 is over here. -1, 5 is here. 0, 1. And now 1, 1/5, and 2, 1/25. These numbers, again, are getting very small, almost 0, so I graphed them very, very close to the x-axis. So this time the graph looks something like this. Okay, then 30, g of x equals 3 to the x minus 1. This time I made my table to go from -1 to 3 because since the exponent is x minus 1, I adjusted the values for my x by 1 because after plugging in the numbers from -1 to 3, our list will end up going from -2 to 2. In other words, let's think of -1. If I plug in -1, the exponent is -2. If I plug in 0, the exponent is -1. If I plug in 1, the exponent is 0. If I plug in 2, the exponent is 1. And if I plug in 3, the exponent is 2. So I will be, after plugging in, get values from -2 to 2. So I offset by making my list go from -1 to 3. All right, so if I plug in 1, I'm doing 3 to the 1 minus 1 is 0. So it's 3 to the 0, which is 1. If I plug in 2, 2 minus 1 is 1, so 3 to the first power, which is 3. Plug in 3, 3 minus 1 is 2, and 3 squared is 9. Plug in 0, I'm doing 3 to the 0 minus 1 is negative 1, so it's 3 to the negative 1. We know that means 1/3 by the rules over here. And if I plug in negative 1, I'm doing 3 to the negative 1 minus 1 is negative 2, so 3 to the negative 2 means 1 over 3 squared, or 1/9. And this time I'm going from negative 1 to 3, negative 1, 0, 1, 2, 3. Again, I don't devote any space for y being negative because none of the y's comes out to be negative. My highest value is 9. I don't mind graphing up to 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so 1, 1, 2, 3, 3, 9. And then these get kind of small. Again, 0, 1/3 is not very high at all. And negative 1, 1/9 is even lower. So it goes something like this. Then finally for 34, g of x equals negative 3 to the x. Well, you're really doing the same thing as a list for 3 to the x. Let's just pretend it's not there. And then put a negative in front of all my answers. So in other words, minus, 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 forget about the negatives, and then just do 3 to the x. So negative 3 to the x, again, that doesn't mean the base is negative 3. The base is actually 3. The base is 3, so you work out 3 to the x and just put a negative in front of everything. So I figured out, well, I might as well just put the negatives once and for all, and there it is. Okay, so ignore the negatives. I've already taken care of the negatives. Put in 0. 3 to the 0 is 1. Plug in 1. 3 to the 1 is 3. Plug in 2. 3 squared is 9. Negative 1. 3 to the negative 1 is 1 over 3. And plug in negative 2. 3 to the negative 2 is 1 over 3 squared, or 1 over 9. And again, these are all negatives. So this time for the graph, all the values are negative, so I don't devote any space to positive values. So my graph looks like this. So x is going from negative 2 to 2, but y goes from 0 down to negative 9 this time. All right, so I plot 0, negative 1 is here, 1, negative 3, 2, negative 9, negative 1, negative 1/3, and negative 2, negative 1/9. These get real close to the x-axis again. So the graph looks something like this. All right, so these are 4 of the graphs for this section, 9.3, graphing exponential functions. All of the graphs will look something like this. All right, so this is Melham's Math 60, section 9.3, page 784 for Thursday, the 23rd of April.